All right, students, welcome back to class. Now, I would like to show you guys uh, how to identify primary carbons, tertiary carbons, secondary carbon, and quaternary carbons. So we are going to denote primary by P. Anything P is primary carbon. Then secondary we use S to denote that. Then tertiary we use capital letter T. Then quaternary we use capital letter Q. So how do you know a carbon that is called primary carbon? How do you know a carbon that is called secondary carbon? How do you know a carbon that is called tertiary carbon? How do you know a carbon that is called quaternary carbon? That's what we want to do now. Now, firstly, let's consider this structure. Consider this structure. Now, we have C, 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 C. Now, how many carbon atoms do we have here? We have 1, 2, 3, 4 carbon atoms. So number 4 in the homologous series is what? Both. Now, since there is no double bond, it's single bond all through. So this is butane. So since it's a straight chain of butane, there's no branch. We say N-butane. That means normal butane. Straight. This one means straight chain butane. That is the meaning of that. Now, how about the carbon present now? We have, how do we know something like designate their position to them, whether it's primary, secondary, tertiary, and all. So let's look at how to do that. Now for the carbons present, remember that remember that we have hydrogen here. We have hydrogen here, but I will not be putting it into. We have hydrogen here. We have hydrogen here. We have hydrogen. 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 Now, why is this one having 3 hydrogen? This one is having 2. This one is having 2. This one is having 3. Why is it like that? Because a carbon atom must be bonded to 4 bonds. Each carbon atom must be bonded to 4 bonds. Once it is 4, stop adding hydrogen to it. You check this carbon atom now. We have 1, 2. We have 1, 2, 3, 4 bonds. Check this particular one. We have 1, 2, 3, 4 bonds. Check this one. We have 1, 2, 3, 4 bonds. 4 bonds must be attached to the carbon atoms. Very, very important. So that's why some are having 3 hydrogens, some are having 2. So all this carbon, this one now that is having 2, this one now, that is called methylene. That's what we call it, methylene. Then this other one is also called methylene. This other one is also called methylene. Methylene is like this. You have a carbon atom, then hydrogen, then the bond will be here, That's what we call methylene. I can try to also write it this way. I'll just write CH2, and I'll put a bond there, It's also methylene. So please take note of that. It's very, very important. Then they can ask how many methylene groups do we have here? We have 2 methylene groups here, which is this and this. We have 2 there. So take note of that. It's also very, very important. So this is the normal way of writing it, but I will not be writing it this way because of space. So I will not be adding the hydrogen to it. So if this compound now, which is butane, loses 1 hydrogen, let me just remove 1 hydrogen now. Let me remove 1 hydrogen. I want to remove 1 hydrogen. Let's say this hydrogen is gone. Automatically, if you remove 1 hydrogen from alkanes, it will become butyl. The name will change to butyl. We'll move from alkane to alkyls. I've already explained that when we're doing the classification of organic compounds. So this one is now N-butyl now. This one is now called N-butyl. Also take note of that. It's very, very important. When alkanes lose 1 hydrogen, become alkyls. So let me go back to the normal form of the drawing, because that is what we'll be using. So remember, all the carbons are attached to hydrogen atoms. So remember that is very, very important. But I am not going to include that because of space. Because of space. Now, this carbon here that is attached to just one carbon, or that has just one bond. This carbon that has just one bond is called primary carbon. That's what we call it. We call this one primary carbon. This one that have just one bond is also called primary carbon. This one that has two bonds is called secondary carbon. This one that has two bonds is called secondary carbon. It's not just two bonds, it's attached to two other carbons. That is the best way to even explain it. Any carbon attached to one carbon, just one carbon, is called primary carbon. Any carbon attached to two carbons, two other carbons, this carbon is attached to this and this, with this bond and this other bond, is called secondary carbon. This one is also attached to this and this. So this one is still secondary carbon because it's attached to two other carbon. So that's how we do know primary and secondary. Now, which one is now tertiary carbon? Let's consider this structure. Let's consider something like this. Let's consider something like this. Let's say we have something like this. We have C, 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 C. We have C. And if you can see this. So this carbon here, this first one is attached to just one carbon. That is primary. This carbon is attached to just one. That is primary. This other carbon is attached to just one. It's primary. This carbon is attached to two carbon. That is secondary. But this other carbon is attached to 1, 2, 3 carbon. That is tertiary carbon. Any carbon attached to three other carbons is called a tertiary what? Carbon. That's what we call it. Tertiary what? Carbon. What do I call it? Tertiary carbon. Why is this one called tertiary carbon? Because it's attached to this. It's attached to this, also attached to this one. Then why is this one? Why is this one called secondary carbon? Because it's attached to this and it's also attached to this. Why this other one? All these ones called the primary carbon because they are attached to this. Only one carbon. They are attached to only one. They are attached to only one carbon. That's why they are called primary carbon. What about we are not having something like this? Let me say we are not having something like this. Let's say we are not having something like this. But we are going to, these things are very useful when it comes to naming organic compounds. So let's say we now have something like this. We have something like this. C. We have C. We have C. We have C. We have this. We have this. We have this. So let's look at the position of all these carbons now. Now this carbon, this one, and this, they are just attached to one carbon. Check. They are just attached to only one carbon. They are attached to only one carbon. So automatically they are primary carbon. This one is primary. Even this one is attached to just this carbon. It's also primary. So it's still primary carbon. Then this carbon here is attached to this, and this. That is, it's attached to three carbons. Remember, if something is attached to three carbons, what do we call it? We call it what? Tertiary carbon. Tertiary what? Carbon. Tertiary carbon. Now, what about this other one here? This last one. This last one is attached to this. So it's attached to four other carbon. So this one that is attached to four other carbon now is called quaternary carbon. That's what we call it. Quaternary what? Carbon. You take note of that. So generally, if we have one carbon, if carbon is attached to one carbon, we call it primary carbon. If carbon is attached to two carbon, we call it secondary carbon. If carbon is attached to three carbons, we call it tertiary carbon. If carbon is attached to four carbons, we call this quaternary what? Carbon. Please take note of this. It's very, very important. Now, how do we use all these primary, secondary, and so on? So let's go. Now, let's consider this structure. 1, 2, 3. And let's assume this structure is attached to another structure. Let me use this so that you see too. So that you see how important the stuff is. How important the what? The stuff is. Now let's consider this compound here. Now remember I told you that this is called propane. This is called propane. We have 1, 2, 3 carbon atom. And if it loses one hydrogen, then it will become, okay, let me therefore do it this way. Let's say we now have an archaic, that is, this arrow means, okay, let me not use arrow. Should I use arrow? This arrow means what? Archaic group. That means this arrow is the parent name. That's the meaning. That's what I'm trying to say. This arrow is the main name of this compound. This one is just a substituent. That's what I'm trying to say. Now you should know the meaning of parent name and substituent from our nomenclature in organic chemistry. There's a little, we did a little nomenclature in organic chemistry. So if there's still time, I'll still try my best to just do a review class on that. Before you name organic compound, look at what you looked at. The first thing you look at is, let me just show you a little thing. The first thing, you first of all just check. When you have C, let's say C. Then, okay, let me not make it complex, too complex. Let's say C. Let's say C. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let me just include this one. Let's say C. So if you look at this compound now, look at this compound. If I tell you what is the name of this compound, the first thing you look at is to check the longest carbon chain, the longest continuous chain here, which is you count from any end. This is one end. This is an end. You have an end here. You have an end here. You can count from any of those ends. You are free to count from any end you like. But sure, when you are counting, you can't. You know how to count, like you know how to do numbering, like 1, 2, 3, 4, 5, 6 to infinity. If you don't know how to read 1, 2, 3, you may not be able to count it, because you are still using 1, 2, 3 that we started in primary school. So you should be able to call those numerals, those normal numerals. So if I decide to start from here now, I'll have 1, 2, 3, 4, 5, 6. That is one way. I may have 1. That is one way. I may have 1, 2, 3, 4, 5, 6, 7. That's another way. You start counting from one end to another end. You can even start like this: 1, 2, 3. You are still free. I can even decide to count it this way. Look at it. I can even decide to count it this way. Let's go this way. 1, 2, 3, 4, 5, 6, 7, 8. You see, this one is giving me 8. This one is already giving me what? 8. This one is giving me 8. Then you will count from one end to the other end and check the one that will give you that is the greatest number of carbon atom. That is the longest carbon chain there. That will be the parent name of that compound. So for example, now I'm already suggesting, or I'm already saying that the parent name of this one is what is it called? Is number 8, which is octane, because that is the longest chain here. Then after you have counted it, maybe you have counted to get the parent name. Let's say we count now. You count from either you count from this place like this now, since that is the longest chain, or you count like this, since that is the longest chain. Or let me also check this. We have 1, 2, 3, 4, 5, 6, 7. That is 7. It's not to it. Let me start counting from here. Let me check it. 1, 2, 3, 4, 5, 6, 7. It's not up to it as well. So that's not up to it. So 8 is the longest. 1, 2, 3, 4, 5, 6, 7, 8. 8 is the longest chain here. So after you have numbered the 8, so that means 8 is our parent name. That means the name is going to be opta. I just say opta, or just say opt, because octane is 8 for alkanes. Then you now check, is there any double bond? There's no double bond. Is there any triple bond? No triple bond. Everything is what? Single bond. Then you are good to go. So it's obtained. The parent name is obtained. Parent name is obtained here. Then the next thing you do, remember the first thing you do, you count to get what? The longest continuous carbon chain. The longest continuous, that will be the parent name of that compound. Then the next thing, after you have counted it, maybe we have counted it now, we are having something like this. This is the chain. Then anything not along with this chain is called a substituent. So this one now will become a substituent. This is what I'm trying to explain now. This is what I'm trying to explain in this place, so that you know how to name this substituent. Now this substituent now is called isopropyl. I will show you why it is isopropyl. That's why we are here. We are not here to name organic compound. You can go back to our nomenclature in organic chemistry to learn how to name organic compound. So that is how you name organic compound. All these other ones that are not along with this chain are called substituent. That is what I'm talking about. If all those things we are doing are substituent, like this C, and C, if this one is the parent name, just like what I did just now, then this one is now the substituent. Now if this substituent, we check now, is attached to the parent name, we check where is the parent name attached to. It's attached to this carbon. Don't look at this bond, because this is not a carbon. This is an alkyl group that is very long. That is the parent name of that compound. Or I can also decide to do it this way. I will say this one is added. I'll say that means I'll just cut it like this. That means this part is going to the parent name. It's going to join a parent name. So we are looking at this now as a substituent to name this. I'm going to do it like that. But I'll just be using arrow, where arrow is the parent name. Arrow is the parent name. So that's not a double bond. Arrow is the parent name. So take note of that. So if this one is a substituent, you check. We have 1, 2, 3. And this bond means it's losing one hydrogen atom. So it's supposed to be propane. Since it's losing one hydrogen atom, it will now be propyl. It will now become propyl. Then you now check this continuous bond. Which carbon atom is it attached to? Is it primary carbon, secondary carbon, tertiary carbon, or quaternary carbon? That is the next thing I'm going to look at now. The next thing we are going to look at now. Now let's check the carbon this continuous, this chain, this parent name is attached to. Let's check it and see. Let's check. If you check, it is attached to. Now check, what kind of carbon is this? Is this, how many carbon is this carbon attached to? This one is not a carbon, so we are not considering that. So if you check very well, you discover that this carbon is attached to just one carbon. So since it's attached to one carbon, it is a primary carbon. So since this primary carbon is attached to the parent name, automatically this one will become N. Then you call the name of this compound, which is what? Propyl. And if it is N, even though you don't put that N, there's no problem. Even though you don't even put this N, that N means it's the normal propyl, it's not an iso. Even though you don't put the N, it's just propyl. You are free to call it propyl. You are good to go. You can call it propyl, no problem. So if I want to call this one now, assuming this one was obtained, and this carbon atom is attached to maybe number 3 carbon inside that long chain, I'll just say 3 propyl obtained. I'll just call this one propyl. That's what I'm going to call this one. Then, what about if this arrow is attached to this other carbon atom? Let's say this parent name now is not attached to this one. Let me draw it well so that you see it. Let me draw it very well. But this thing is very important when it comes to naming organic compounds. It's very important. So let's say we have something like this. C. You are seeing here. C. Then this one is now attached to the parent name. This one is now attached to what? The parent name. So this is now our substituent. That is now what? Our substituent. So what is the name of this substituent? You will check. Where is this arrow attached to? It is attached to this carbon. Now you now check how many carbon is this carbon attached to. It is attached to 1 and 2 carbon. So that is a what? A secondary carbon. This carbon is a secondary carbon. Now we're supposed to now call this compound now secondary sec-propyl. That's what we're supposed to call it, sec-propyl. But since there is nothing like sec-propyl in organic chemistry, sec do start from 4 carbons and above. Then we relax ourselves first, and the name will now becomes isopropyl. That's why we're not going to call this one isopropyl. That's why I'm going to call this one now isopropyl. Iso what? Propyl. And if you check, you discover that for this isopropyl, in this carbon atom that we are taking regards to, we have 2 other carbons here that are methyl group. They are called methyl. This one is called methyl. This one is called methyl because it's just 1 carbon losing 1 hydrogen, 1 carbon losing 1 hydrogen. When 1 carbon loses 1 hydrogen, just 1 carbon there, we have other hydrogen here, 1, 2, 3. That's 3 hydrogen. 1, 2, 3 hydrogen. So this compound now supposed to be sec since it's attached to secondary carbon. But since there's no sec in propane, in prop, so we call it isopropyl. That's what we call it, propyl. So that's the name of this one, isopropyl. That's the name of this one here now. It's called what? Isopropyl. Isopropyl. So please take note of that. It's very, very important. So if they ask you what is the name of this compound, maybe they'll draw it like this, draw it like this. Maybe they just let me draw it in a very good way. Draw it like this. So if you see something like this, let's say you see something like this, that means we have a carbon atom here. We have a carbon atom here. We have a carbon atom here. Then let's assume the thing is not like this. Let's assume it's not like this. Then they now say this one is attached to a parent name. That's attached to a parent name. They now ask you what is the name of this one. This stuff you are seeing here is equivalent to something like this. C. It's equivalent to something like this. That means we have a carbon here, we have a carbon here, we have a carbon here. So if this central carbon is losing 1 hydrogen atom and you are not having a continuous chain attached to that central carbon atom, for propane, for propyl, I told you guys that the thing will be called what? Isopropyl. So this one now, this one is called isopropyl. That's what we call it, isopropyl. Take note of that. Best way to even know it, just take note. When you have propyl, and the one losing hydrogen atom is the secondary carbon. Check now, which one is losing? We have 1, 2, 3. This one is called propane. Then if this one loses 1 hydrogen atom, then we'll put a bomb there. That is called propyl. Then if this central one loses hydrogen atom and they now join it to a parent name, it will be called isopropyl. Take note of that. It's very, very important. Let's continue. Let's go to sec now. Sec will start from 4 carbon atoms. Let's see, 1, 2, 3, 4. Now, if this one loses hydrogen atom, if it's not attached to a parent name, this one will be called normal, because this one is a primary carbon. It's attached. That primary carbon is the one that is attached to that parent name. So this one is called normal butyl. So I just this compound now is called just butyl. That's what we call it, butyl. That's just butyl, or normal butyl, N-butyl. But look at another thing. Let's assume we now rearrange it. And the one losing hydrogen atom is either of this and this. Look at it. If this one loses hydrogen atom still, it's still the same thing as normal butyl. It's just the same. For example, now if you put the arrow here, it's still normal butyl because it's still primary carbon that is losing it. But if this secondary carbon loses the hydrogen atom, maybe this one is not attached to arrow now, automatically This one now as a substituent will be called secondary, or you call it sec butyl. That's what we call it. Sec what? Butyl. Now, this one will be called what? Secondary. It's supposed to be secondary butyl, but I will just call it. We don't put the secondary. We just say this guy now is now called sec butyl. That is all. Now another way to write something like this. Now look at it. Write something like this. You see it? That means we have a carbon atom here, a carbon atom here, a carbon atom here, a carbon atom here. Anytime you see anything, anyway, you see something like this, it means each end has carbon atom, and each branch, this what we call it, vertices, has a carbon atom, or edges has carbon atom. So this is an end. There's a carbon atom here. This is an end. There's carbon atom. This is a vertex. There's a carbon atom there. This is a vertex. There's a carbon atom there. So how many carbon atoms do you have? 1, 2, 3, 4. So this one you are seeing here, something like this is called butane. That's what we call it. Take note. Butane. Butane. Then, and I told you guys that if this either this secondary one or this secondary one loses hydrogen atom and is not joined to a parent name, automatically this upper one will be called sec butyl. That's what I'm going to call it. Sec what? Butyl. That's what I'm going to call it. Sec what? Butyl. Take note of that. It is very, very important. Very, very what? Important. If you still carry it to, maybe move to this place. Move to this place. It is still secondary butyl. It's still sec butyl. It's still sec butyl. Now, what if we now have something like this? We have C, we have C, we have C, then we have C. We have C here. We have C here. I already told you if this one lose hydrogen atom, it will become sec butyl. That this one is not attached to parent name. This one is not attached to parent name. So this upper one will become sec butyl. Then if this also lose hydrogen atom, this one will become sec butyl as well. It become sec butyl. It's still the same. It's the same thing. Then what about we now have something like this? We now make an isomer of this. Now, how many isomers can we form here? I think we are just going to form one isomer from this place. The isomer is going to be, let's say 2-methyl propane. Not like this. If I want to make an isomer of this now, let me just write it again so that you see it. Isomer means a compound that have the same molecular formula but different structure. Look at this. We have 1, 2, 3, 4. Can you see this? Then I want to make an isomer of this. That means a compound that will have the same 4 carbon atoms. It will still be an alkane, because this one is an alkane and because there's no double bond. It will still be an alkane belonging to the same group, but it will not be something like having branches. It will not have like branches. Like I want to do like a structural isomer now. That's what I want to look at now. So let's say we have something like this. We have 1, 2, 3. Then we now have put another compound from there. So this one, this is an isomer of this. This and this, they are both isomer to each other. So this one is called normal butane. This one is called butane. What this one is 2-methyl propane. 2-methyl propane. That's what we call this other one. Because this if you start to count now, we're going to count 1, 2, 3, sharp. So this other substituent is attached to number 2 carbon. That's why we are saying 2, and it's a 2-methyl propane. If you know how to name organic compound, that is not a problem to you at all. So the isomer of butyl is this. We have 1, 2, 3, 4. That's what we're having. That's what we're having. So now, if this carbon atom now, let's say for example now, any of these end carbons any of these end carbons, because we don't even have secondary carbon yet, so we cannot make the only thing we can make from this place is either iso, or we will make Tert. Any of the two, we can make either iso or Tert from this place, because we just have primary and tertiary carbon in this place. Check it. The carbon that I just sent out are primary carbons. This central one is a tertiary carbon because it's attached to 3 other carbon atoms. Just take note of that. Check. So now, if I make this place my continuous chain and this one now becomes a substituent, how many carbon atoms can you see there? That's what you say. How many carbon atoms do you have there? We have 4 carbon atoms. So what are you now going to call that 4 carbon atom now? We are going to call it is an isomer of butyl. So we are going to call this one isobutyl. That's what I'm going to call it. Iso what? Butyl. Then, even though the continuation is starting from here, the thing is starting from this place, this one is attached to it's still isobutyl. Even though you bring it to this place, so it's still isobutyl. Any end, if you start from any end, is isobutyl. Remember the normal compound was this, which is an isomer of butyl. This is an isomer of butane. This is an isomer of butane. This one is isomer of butane. This one is an isomer for butane. Take note of that. How many carbon atoms do you have? 1, 2, 3, 4. We have this is an isomer of butane. So if you have let's say we have something like, if you this one loses one hydrogen, if any of the end carbon loses hydrogen atom, it's going to be isobutyl. That's what we are going to call it. So that's what we call isobutyl. Now let me draw it again so that we just want to explain that sec butyl. Look at this. We have 1, 2, 3, 4. Remember this an isomer of butane. Now, what about we now attach our parent name to this? Then we are now having something like this. Arrow. Then this one is not going this way. You check this arrow. Which carbon is it attached to? Is it a primary carbon, secondary carbon, or tertiary carbon? You check very well. The arrow is attached to a tertiary carbon. Why do we call it tertiary carbon? Because it's attached to 3 other carbons. It's attached to 3 other carbons. So this one now, this compound now, this one is called Tert butyl. That's what we call it. Tert what? Butyl. Because this continuous chain is attached to a tertiary carbon. It's attached to what? That's why I was doing all those primary, secondary. If the continuous chain is attached to primary carbons here, it become, since it's an isomer of butyl, we just call it isobutyl. The compound actually was an isomer of what? Butyl. The compound is not a propane. This compound is not a compound of propane. It's just an isomer of butyl. And if you want to name it, the parent name will be propane, which is 1, 2, 3. The longest chain there is 3, which is propane. But this one is still there. We are still going to call down to which is 2-methyl propane, which is an isomer of butane. So if this one loses one hydrogen atom now, it can either loses when 2-methyl propane, or when an isomer of butyl loses one hydrogen atom. It's going to either lose it from primary carbon or tertiary carbon. If it loses it from primary carbon, any of the primary carbons there is the same. If you check, the thing will be the same thing. Then we are going to call it isobutyl. Isobutyl. If you lose it from the tertiary carbon, there we are going to call it Tert butyl. We are going to call it Tert butyl. Take note of that. It's very, very important. So we already go to the climax of the lecture. So let me draw this one now. Let me draw this one now in a very lovely way, the way they do put it. So let's say we have one like this. Then we have something like this. This one is attached to the normal carbon. You say, what is the meaning of this one? Remember, this is what we were doing just now. That we're calling an isomer of butyl. That we're having C here, we're having C here, we're having C here, we're having C here. So like this now. Let me draw it somewhere so that you see it. It's better you understand this thing. It's very, very important. We have, let's say we have something like this, This was the actual one butyl we draw just now was like this now. It was like this is why I'm drawing it to have maybe branches. Is because look at what we had. We are having 1, 2, 3, 4. This is what we are having now. So if I want to draw it now, I cannot just draw it like this. No, no, it's not possible. We don't do it like that. You have to ensure that where carbon atom is, there is something like a vertex there, or a colon there, a sharp edge there. So in this place now, I'm going to make it a sharp edge, something like this. So that means we have carbon here, we have carbon here, we have carbon here. That's how we do it. That's how we do it. Then this other one now will be like this. Will be like this. So I don't need this. I don't need this one. I don't need this one again. So I already explained that. So I now told you, if this central carbon is the one, if that central carbon is the one losing the hydrogen atom, something like this. For example, let's say we have something like this. This is what we are having before. Or let me just draw it the same way, so that some students will not be confused. Then if this central one is the one losing hydrogen atom, you see, what is the meaning of this one? This thing is called Tert butyl. That's what we call this one. This one that look like this. Do you see it? So this one now is called Tert butyl. That's what we call that. Because this continuous chain is attached to tertiary carbon. Carbon attached to 3 other carbons. Then, what about if it's like this? What about if it's like this? I'm just using all this line method. What about if it's like this now? We are not going to attach the continuous chain here. We are not going to do that. We are going to either attach it to this one, or we attach it to this one, or we attach it to this one. If you attach it to any of those ends, it will be the same. Should we check it? Alright, look at it. Let's attach to C now. Let's before attach it to this end. What do you see? Check this one. It's like Y. Abi? It's like Y. It's not like Y. It's like Y now. It's like Y. So that is called, this one is called isobutyl. Let's attach it to the other side. Check this one. You check it like this. Then just turn your foot. The thing is still like Y. It's still like Y. Still like Y. Still like Y. That is the isobutyl. If you will move it, I come and attach it to this side. See, what is this one? It's still isobutyl. It's still just like Y. It's still the same thing. It's still the same. So take note of that. It's very, very important. Now, what about when I have something like this? When I have something like this, let's go and have something like this. Remember, when carbon atom is attached to secondary carbon from 4 carbons and above, it's called sec. When it's attached to quaternary carbon, it's called what? Tert. When it's attached to primary carbon for isomer of a compound, it's called what? What do we call it? Let's take note of. It's very, very important. So let's look at this. Let's see, we now have 5 now. So this one is called pentane. What do we call it? Pentane. That's what we call this one. Pentane. Now, because of time, I'll just end it here. Now, I can start to write an isomer. As I start to rewrite this pentane this way, look at it. I can start to write it this way. Look at it. I start to write it this way. I just write C 1, 2, 3, 4. This one is still pentane. This one is still pentane. This one is still pentane. But this pentane, is an isomer of pentane, and we can call it, let's say 1, 2, 3, 1, 2, 3. If you come from anywhere, it will still be 3. So that will be, this one will be something like a 2,2-dimethyl propane. So it's 2,2-dimethyl propane now, which is an isomer of pentane. Now, if for this pentane, if the continuous edge, for example now, you check all these edges, check the edges. For example now, if we cycle this one to be 1, this one is not a tertiary carbon. This one is primary. This one is a quaternary carbon. Because of that quaternary carbon that is there, for example now, look at it. Let me erase something. Erase something. Got it. We have a quaternary carbon, primary, 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 primary. Now, because of this quaternary carbon that is here, if any of these continues, remember when we're having butane, when we're having isomer of butane, any continuous chain attached to the primary carbons will be isomer of that. But because of this quaternary carbon that is here now, we will not call this one continuous, like maybe attached to a continuous chain, an isomer of pentyne. We cannot call this one isopentyne. No, it's not possible. This one will bring a new name, because this one now is like this. It's not forming something like Y. It's not forming something like Y. Check it. We will check it when we are doing the line method. So if I'll just, what I'm going to do, this one is not attached to a new name. So I'll just cycle this one. I'm just going to cycle this. So this whole compound now, since you have a quaternary carbon here inside, then we will call it neopentyne. That's what we call it. Neopentyne. Because of this quaternary carbon here. Even though you attach it to this side, you still go and make the quaternary carbon. Attach it to this side, you still go and make this quaternary carbon. Attach it to this side, you still go and make the quaternary carbon. So we are going to call that one, we are going to call this one neopentyne. Neo what? Pentyne. So you can also write it this way. Write this way. Okay. Got it? So that you'll be able to differentiate it from. Remember, this one was called what did we call this one before? We called this one Tert. Remember, we call this one Tert-butyl. Then if this Tert-butyl now, it's just like if that's something that looks like Tert-butyl now continues. Let's say the thing now have a continuous chain. Something like this. They will now have something like this. This is the one we called neopentyne. This one. We call this one neopentyne. We will not have a carbon atom here, carbon atom here, carbon atom here, carbon atom here, carbon atom here. We will not call it Tert-pentyne. No. Because this one is not even attached to a tertiary carbon. It's attached to a primary carbon. Because of this quaternary carbon that is here, linked to this primary carbon, that's why we are calling it neopentyne. And the formula is like this. Look at it. It's like this. You write it in condensed form. You write C H CH 3. You put 3 here, and we have 3 of it. You have C, then we have CH. You have CH2. Then this is the correct way. Yeah, this is the correct way. We'll do another video explaining condensed form. Let me just first start with this very simple one. All right, let's go. Now look at the first thing I'm going to do. How many we have? Okay, just look at it. Look at this. This one means we have 3 times 6. That is 3C. That is we have 3 carbon atoms. Then let me know if we explain that. Let me just tell you, have 3 CH3. I have 3 of CH3 here. 3 of them. So you take note of that. We have 3 CH3. We have, so if you have 3 CH3, that means already 3 carbon, 4 carbon, 5 carbon. I'm just going to write. If I 1, 2, 3, 4, 5. Where will I have 3 CH3 here? This one can only have 2 CH3. I'll have 3 CH3 here, and all the CH3 are in this place. No CH3 is even at the end. Only one CH3 I can form here. So this one is wrong. So you cancel it. This is not the right way. Again, then you start from, okay, so let me start from this central one now and leave this one first. Then we leave that CH3 first. We start from the next carbon. We have 1 carbon, we have 2 carbon with 2 hydrogen. Then another bond is still going. So forget about that bond, there's no problem about that. Then what about this CH3? You can come here, you put 1 CH3 here. So H3C. Then put 1 here, CH3. Put 1 here, CH3. Did it work? So well. It worked out. So what you do, if you see a condensed form, just leave that CH3 you are seeing. If it's CH3, leave it, then continue from the next carbon. because that next carbon will be the one to carry those CH3 that you are seeing. So please take note of that. It's very, very important. So this is the right way to write this one now. So this one is called neopentyl. That's what we call it. Neopentyl. Another way to write it is just like this. Write something like this. This is still neopentyl. Did it shock you? It's still neopentyl. That's another one. That's another one. Let me shock you again. This is still neopentyl. Look at another one. Okay, let's stop playing. Let's just do revision. Remember, we're having something like this. I said this one is called what? Isopropyl. Isopropyl for this. We have another one like this. Remember, we said since this one is attached to secondary carbon, it's supposed to be sec-propyl. So since there's nothing like sec-propyl, we're not calling it isopropyl. So look at one thing about iso. If you check this line, that is this continuum line must be attached to a central carbon. This one now is a central carbon because the same thing we have here is just the same thing we also have in the other side. So if that continuum line is attached to the central, that is the carbon at the center, I have the same thing here and the same thing here, we call it iso. And in most cases, we will have only one carbon. That is all. There will not be any other carbon there again. Just one carbon. No carbon will be attached again. Just one carbon. We'll do it for isobutyl. We'll do it for isopentyl. You see what we'll be having here. So this one is isopropyl. Then we have another thing like this again. This one is what? Sec-butyl. We have another thing like this again. So this one is what? Isobutyl. Check this one. I didn't know the same. They are the same. You will have something like this V there. Sorry about that. This was our isopropyl. Then our sec-butyl was like this. So it was attached to secondary carbon. So we call this one sec-butyl. Then our isobutyl was like this. They just take this one more longer. Call our isobutyl. Then our tertiary was like this. We call this one Tert-butyl. This one is isopropyl. This one is sec-butyl. This one is isobutyl. This one is Tert-butyl. Taking note of that is very, very important. So let's work with iso now. I'll leave all those Tert and sect. Let's work with iso. So this is where we started from. Isopropyl. Isobutyl. Let me do it very well. Isopentyl. Check. We have 1, 2, 3, 4, 5 carbon atoms. That's isopentyl. If you also do it again, then you consider something like this. That will be isohexyl. So if the thing is just going, it will give you iso, then you call the next name. If you add one carbon again along this chain, just iso, you call the next carbon. If it's 6 carbon, isohexyl. If it's 7 carbon, isoheptyl. If it's 8 carbon, isoheptyl, and so on. It's as simple as that. So I'm going to stop this class here because it's getting too long. So I will do condensed form in the next video. See, this is also neopentyl. You can also see it, neopentyl. This is just neopentyl. You can see it, alcohol. Because it's having OH group, we call it neopentyl alcohol. You can see the condensed form. If I tell you now to write that condensed form, I hope you'll be able to write it. I'll be able to write that condensed form. You can see this is what I'll be trying to explain to you guys since. So you can also just identify them here now. Ensure they are in your head. Isopropyl, sec-butyl, Tert-butyl, isobutyl. You can see isopropyl and isobutyl, they are almost the same. You can see the two of them. You can see the Tert-butyl I explained before. You can see the sec-butyl and I explained before. So thank you.